All right, so let's give this a shot here. This will be the third time for me going all the way through this. We've had some technology issues today, so hopefully all the volumes and everything are turned up where they need to be. Sorry for the delay if any of you guys are trying to watch it at lunch today. So we're going to start to build the unit circle. We're going to do it in little pieces, obviously. It's a huge, huge part of this course. You need to make sure you get a good understanding of this over the next couple weeks. Anything you don't get, ask the questions now, come in and see me. Video tutors online, watch this again, extra practice problems, whatever it's got to be. But these next couple of weeks will really set the tone for the rest of the semester. So we're going to go back to some right triangle trig stuff that you've done in geometry, you've done in college algebra. So I should be able to give you a right triangle that, you know, looks any way. Okay, let's say we flip this guy around like this. We should be able to pick any angle, and you guys should be able to tell me adjacent, opposite, hypotenuse. So think about your SOHCAHTOA. Let's say I pick this. Okay, clearly opposite, adjacent, hypotenuse. Okay, let's say I take this guy here. Here's my angle. Here's my opposite. Here's my adjacent. Here's my hypotenuse. Okay, now I drew these triangles this way for a reason, because that's how they're going to look in the unit circle. Okay, next slide's going to throw a lot of stuff at you guys. Pause it, get it in your notes, watch it as many times as you need to, and we'll start practicing this stuff tomorrow. Okay, here's what it looks like. Unit circle, okay, this is part of it. So what we're going to do, take an x-axis, y-axis, throw a circle on there. You'll see what these little hash marks are as we build this entire thing. Okay, so we picked a point right here. Okay, it's an xy point because we made an x-axis, y-axis. Okay, so it has an x-coordinate, it has a y-coordinate. Okay, we have to make the right angle or we can't use any of this SOHCAHTOA stuff. Here's our counterclockwise angle. That's going to be positive. That's going to be our theta. Radius is going to be a 1 because it's the easiest number out there. Okay, later we're going to make the radius things that are not 1, but for right now, it's a 1. Okay, so clearly it's an xy point. We're picking it in quadrant 1 because it makes things really easy to look at, but just understand you could pick a point down here. You could pick this point. You could pick this point. You could pick this point. You can draw your triangles in there, and we'll talk about what they all look like in those respective quadrants. They're going to have an x value, they're going to have a y value, and they're going to have a radius of 1 in this case. Okay, so we're going to pick an easy one to get all this stuff set. Now, given this triangle, okay, here's the theta. Theta is always going to revolve around this origin. You're not going to have thetas coming off the circle. You're not going to have thetas, you know, over here on this side. All your thetas will be around your origin. Okay, so this triangle here, if I want to do a sine, sine is opposite over hypotenuse, so y over 1, or just a y. Okay, so you can think about sines being y values, but just be careful because it only works when the radius is 1, and you'll see later. Okay, cosine is adjacent over hypotenuse. So here's your angle, here's your adjacent, here's your hypotenuse, x over 1 is just an x. So when you see cosines, you can think x's, but only because this radius is 1. Okay, always, always draw your triangle before you start grabbing values. Okay, tangents, opposite over adjacent. There's the TOA piece. So a tangent is a y over an x. Now I'm going to replace it with a sine over a cosine because this is going to come in when we start doing identities. Okay? So yeah, we have a triangle. You can go this over this, but also think about it as sine over cosine. Okay? Cosecant. That's what this thing stands for here. You guys are familiar with these. These three may be new to you. Okay? These are what's called reciprocal functions. So a cosecant is 1 over the sine. All we're doing is flipping it. Okay? Secant is 1 over a cosine. So 1 over x. If a cosine was x over 1, secant is you just flip it. You got to figure out what's going to be best for you to memorize these, I've always looked at it this way. For some reason, I see that S in the middle, and I think, oh, this guy goes with sine. For some reason, I see the C on the end, and I think this goes with cosine. Okay. Cosine starts with a C, ends in an S. This guy's just backwards. Ends with a C, starts with an S. So however you got to figure out to memorize those, please do. Cosecant goes with sine. Secant goes with cosine. Last one's cotangent. That one's easy to remember. 1 over the tangent. If the tangent was y over x, cotangent's x over y. So if a tangent was sine over cosine, cotangent is cosine over sine. Okay. One way you can always remember cosines are going to be x's other than your triangle is C comes first in the alphabet before an S, X comes first before a Y. So the first early letters and then the 2 letters after that. Okay? So take as much time as you need to get that picture. You don't have to draw it exactly like this, but make sure you have these 6 things defined with a picture that you can look at. Okay? Because when I say list the 6 functions, these are them. We'll be doing a lot of that. Okay, let's look at some problems. Let t be a real number, and let p equal -1/2 square root of 3 over 2 be the point on the unit circle that corresponds to it. And I want you to find all 6 of those. So what we can do, you can consider there's your xy axis. You can go throw a circle in. Now this isn't necessary every time, but getting us set up, it'll be real helpful. Okay? So this point is on the unit circle. That's the key. And it's at -1/2 square root of 3 over 2. So it's a positive value. That guy's going to be right up there. Okay? Okay? Always draw your radius, your hypotenuse, back to the origin like this. Okay, you're always going to make your right angle off the origin. So here's your little theta right in there. So we went over -1/2. We went up a square root of 3 over 2. Those are our 2 values. Now just so you can see this, I'm going to show you why the hypotenuse is going to come out to be 1. We want to find the value of that blue line there. Well, we do Pythagorean theorem. So I'm going to take 1/2 squared. I'm not even going to put the negative in there. I'm going to take a square root of 3 over 2, and I'm going to square it. That's going to give me my hypotenuse squared. So 1/4, this is 3/4, equals 4/4, which is 1. Square root 1, you still get 1. So this radius is 1. Okay, now because the radius is a 1, we can directly say this is cosine. We can directly say this is sine. But if you have your triangle, you can grab those just as well. So let's grab the circle and get a new page where we get some room to work. Okay, so let's take this guy here. Let's get all 6 of them. I start with sine for some reason. Find some habit that works for you guys. Okay, here's my picture. Sine is a opposite over hypotenuse. Square root of 3 over 2. Done. Okay, the 1 doesn't matter. Go to cosine next. Cosine is an adjacent over hypotenuse. -1/2. We can grab those from the point, but only because our radius is 1. Next, we go to a tangent. Tangent is an opposite over adjacent. Now here's the one time I'm going to show you how to divide fractions this semester. Okay? You guys need to know how to do it. Square root of 3 over 2. We say divided by -1/2. We don't divide fractions. We multiply by the reciprocal. Okay. Cancel and cancel, and this comes out as a negative square root of 3. So we can say the tangent is negative square root of 3. Now, if you have them written like this with the fraction divided by fraction, and you realize these denominators are exactly the same, they can cancel, here's the reason why. Okay, elementary stuff, dividing by fractions. All right, there's the 3. We just got to go get the other 3 now. When you're going to get these reciprocal identities, yeah, you could go back to your triangle, but reciprocal identities are a little bit tougher to remember because we're not used to doing hypotenuse divided by adjacent. We're always saying adjacent over hypotenuse. So once I have these 3, I'm pretty much done with my triangle. I'm not going to go back there anymore. Okay? I'm going to trust these are correct, and I'm going to use these values. Okay? So after we do a sine, I go do a cosecant, because remember these two are the same, well, reciprocals, but they go together. So I need to take this guy, and all I got to do is flip it. So I'm not using the triangle. So I'm going to take my sine, and I'm going to flip it. Now, you don't want to leave any answers like this. If you're wondering in Algebra 2, college algebra, why you rationalize denominators, now all that practice gets to pay off. Okay? So this is 2 square roots of 3 over 3. That's your answer for your cosecant. Don't give me the decimal for it. Okay, give me the improper fraction rationalized. All right, after cosecant, I go do a secant. Secant, all we got to do is flip the cosine. That guy's easy. -2, done. Okay. After secant, I go do a cotangent. Now, you could go back to this fraction within fraction, but that's a lot of work to flip it. Why don't you go to your final answer for your tangent and just flip that guy? So -1 over square root of 3. Okay, make sure you rationalize this guy. So negative square root of 3 over 3. Okay, those are the 6. So sine, cosine, tangent, and then I do them in the same order again, just the reciprocal identities. Okay, so let's try one more in that quadrant, and you guys can look at the answers here. So let's say t is a real number, p equals x comma y is the point on the unit circle. There's the key phrase again. Okay, and it corresponds to t. Find the exact value of the 6 trig functions, so there'll always be given 6 answers here. And here's the point. So the numbers are a little bit uglier here. Okay, you can make a little graph, you can put your circle in and get your triangle all set up. I'm just going to do the point. So I'm going to go back -1/5, and then I'm going to go up some unknown number. Let's just put it right there. Hypotenuse always comes back to the origin like this. Here's your little theta. Here's -1/5. Here's 2 square roots of 6 over 5. Okay, just to check, I'll show you the radius is going to be a 1. 1/5 squared. 2 square roots of 6 over 5 squared. So this is 1/25 plus 4 times 6 over 25, 25 over 25. So when you see that phrase, you can know your radius should be 1. It's helpful to check just to get some extra practice with this. Because that's the case, we can say sine and cosine are the values from the x and the y. But if you went to your triangle, which I always encourage you to go to first, you'll get the same thing. So you go to your triangle and you want to do a sine opposite over hypotenuse, and it's right there. Okay, the rest of them are on here. Take as much time as you need to look at those guys. Tangent, they did a sine over a cosine and actually took these values. You can go to the triangle and get those as well. Okay, so it can come from the triangle, it can come from other identities or other trig identities as well. Okay, Sine, cosine, tangent, cosecant. So we flip this guy. Make sure you rationalize here. Don't give me a decimal. Give me this as your answer. Okay, cotangent, take your tangent and flip it. Notice this is written a little bit differently. Instead of fraction within fraction, like I did here, this guy's written on the side. Those 5s will cancel out, and you just get that. So we flip it, we rationalize right here, and get your final answer. Okay, so there's 2 that are both in quadrant 2. All right, and these are going to move all around. Just make sure you watch out for x and y values. So let's say we put one down here. Okay, so your triangle would look like this. It always comes up to the x-axis, over to the origin, and back. Okay, this is obviously going to be a positive x. This is going to be a negative y. Your radius will never ever be negative, or hypotenuse, however you want to think about it. Okay? All right, last one here. Let's look at this guy. Find the exact values of each of the 6 trig functions of an angle theta if 4, negative 3 is a point on its terminal side. So notice this guy does not say a point on the unit circle. So we get some angle theta, 4, negative 3 is a point on its terminal side. So I drew 2 circles here. Okay, let's consider this inner one the unit circle. It's going to have a radius of 1, and then we have a bigger one out there as well. So if I go over 4 and I go down 3, I'm going to be somewhere in here. Somewhere in quadrant 4, throw your radius back to the origin. Okay, so this guy's over 4, this guy's down 3, 3, 4, 5, Pythagorean triple gets you there. Okay, and you guys can do that math if you need to. 16 plus 9, square root it. All right. Clearly the radius is not 1. So all we did is we took that basic unit circle and we kept stretching and stretching and stretching it out. So when it says an angle theta and it's got this point on its terminal edge, what we really have is like we did this angle and this guy extends out and out forever. So that point 4, negative 3 is on it. So there could also be this point here, or this point here, or this point here, or this point in here. All those ratios for all those triangles will be exactly the same. Okay, you can even have a big one out here. They're all going to be in some 3, 4, 5 ratio. Okay, but these numbers are a lot nicer than scaling it down to 1. Okay, so some big angle came around this way. It ended on that side, but we're going to use this little theta on the inside. Okay, it's going to be called our reference angle, and we'll get into those. So we got this 3, 4, 5 triangle. You can blow it up like this and pull it out if you need to. Now, this guy should be pretty easy. Okay, no rationalizing, no fractions, things like that. All we got to do is list them. Sine, opposite over hypotenuse, done. Cosine, adjacent over hypotenuse, 4/5. Okay. Tangent. So tangent is a TOA, so opposite over adjacent. Okay, once you have those 3, all we got to do is flip them now. So cosecant, take this guy, flip it. Negative 5/3. Secant, take your cosine, flip it. 5/4. Cotangent, take your tangent, flip it. Negative 4/3. Okay, notice your reciprocal identities always share the same signs. Sine's negative, so cosecant has to be negative. Cosine is positive, so cosecant has to be positive. Tangent's negative, so cotangent's got to be negative. Okay, you can get them from the triangle, or you can use your first 3. I do the first 3 from the triangle. I should probably draw a right triangle. okay, to get those 3, and then I just flip them to get those, to get the final 3. All right, come to class tomorrow with questions.